Hi, this is Magic Switchboard Revealed. Here we have a specially designed circuit that I made. Well, not really. This came from a kit, and this is a part I made. Anyway, I'm about to show you how the switchboard works. First of all, if you don't know what it is, you can look it up on YouTube. I'm not going to perform it how it looks or anything. All I'm going to do is show you how it works. But if you want to see what it is first, go onto YouTube and search for the keywords Magic Switchboard. Find Mini Magic Switchboard, and there's another video called the Magic Switchboard with the same board in the video. Not this one though, but the one in the other video. Anyway, with this board, I have built it. First of all, I built it from the K8055 RS USB experiment interface board, which I bought at Radio Shack. I put that all together. I got me a jack. That's also Radio Shack. I probably got it a few years ago. I think they still have it though. And a Radio Shack power adapter. You know, I like Radio Shack. And perf board, some wires, just standard phone wires, some capacitors that I inherited from one of my friends, and some standard craft beads. We also have some bulbs, and I painted them with some paint that I got from Michael's. So pretty much all the good stuff. My USB cable is just left over from another kit, a Lego kit. Actually, I have two of them, but one of the cables broke, so I switched over. It's just a standard printer cable is all it really is. Anyway, these switches are on the inputs 1 through 4, and these bulbs are on outputs 1 through 4, so it makes it easy. And I wrote a program in Visual Basic to make it all work. Anyway, basically, let's hook it up here. I'm going to plug this in first. It starts blinking, telling me it's connecting, and then it's connected, and then I plug this in second, just for safety reasons, so I don't blow anything. And then I'm going to run my program. It should be running now. You won't really notice anything until I hit the switches. But the way I noticed it working, when he first turns it on, like I just did, but his is a little bit easier. It's pre-programmed to light up all the switches in the right sequence. So that's the first trickery in it. They're already in the right order, and he's just got it set. Okay, so they're already in the right order, so why not just make them all the same until the switches are pressed? Now, switches have been pressed now, so after about 3 seconds after I switched them all off, and of course that resets after each switch is turned off, it starts it over. After that, it doesn't know where the bulbs are at, it assumes. So it assumes that it's going to go all in left to right order. Well, left to right for me is right to left for you. But, so, for example, if I were to switch the blue and the yellow, of course my colors are a totally different order than what he had too, but it still works. And now the yellow's over here, so I did this one first. And of course I can have more than one if I want to too. And then these two. And then of course there's no the connectivity of the bulbs has nothing to do with it. This all has to do with the timing and the memorization. So like for example, if I were to switch two of these around, or actually I'll just switch them all around for the heck of it, you know. Now, in this situation, I have to do it this way. Now of course I can also do it like this. This is another thing, it remembers. It remembers exactly what order they're in after I've done that. So that's how it works. Now the behind his back part on one of those videos, that has nothing to do with the order does not matter. It just so happened that it worked the easy way for him. In his case, well, it was red here in the video, but I don't have to use yellow. In his case, the yellow could have gone anywhere, obviously, because it doesn't matter what switch you hit, it's going to light that one. So he had it right there, and it worked. And it could have lit up any of those, but it didn't. And anyway, but say like, for example, it wasn't the first one. Say like it was this one, it was the green one. Well, all you'd have to do is to say, well, it's just reverse what he said. Is just put, he could have said, well, you could have hit any of these two, but you get it on this one. You got it on that one, so but you couldn't have hit. You could have hit this one too. You know, you just swap the way you worded it around to match what color it was. That was less than 3 seconds, I guess. So actually, I might have programmed it for 5. I can't remember. But anyway, the X amount of seconds on the delay is kind of a thing that's up to the magician. I don't know if my timing is exactly what he had, but it's good enough where I can do it just fine. Well, except I'm not a good performer, so that's why I'm not performing today. And well, just to mention, these switches are pretty much the only thing that didn't get at a store that I know of. I don't know where these switches came from. All I know is I pulled them out of my dad's drawer. So that's about it. Oh, and by the way, these switches here are activated too. But it's useless for this. So anyway, and the reason why there's these capacitors, by the way, is because there's something in electronics engineering called oh, come on now, just slip my mind a little bit. Oh, switch bounce. So anyway, switch bounce is where when you're flipping a switch, when you flip it on or off, there's a point in there where it'll kind of oscillate a little bit when it's kind of not quite on and not quite off. So if you have a capacitor in there, that switch bounce is not going to happen as much, because when it goes oscillating like that, like zzz, it'll still be in this on state. It won't be off right then, or it'll still be in its off state depending on which way it was to begin with. Usually you run to ground. So that's about all I have to say. Can't think of anything else right now. So see you on the tube.